The Calvin cycle. The Calvin cycle takes place in the stroma of the chloroplast. It uses ATP and NADPH from the light reactions to turn carbon dioxide into sugar. The cycle has three main phases: carbon fixation, reduction, and regeneration. The first phase of the Calvin cycle is called carbon fixation. This is where carbon dioxide from the atmosphere enters the cycle. A 5-carbon molecule called RUBP is already present and waiting. An enzyme named Rubisco attaches each CO2 molecule to RUBP. For every 3 CO2 molecules that enter, 3 RUBP molecules are used. When CO2 combines with RUBP, it briefly forms an unstable 6-carbon compound. This compound immediately splits into 2 3-carbon molecules called 3-PGA. At this point, carbon from the air has been fixed into an organic molecule. No energy has been added yet. The carbon is simply captured and held in place. This step is essential because it brings carbon into the biological world where it can be later used to build sugars. And that is the end of the carbon fixation phase. ATP and NADPH produced during the light reactions now enter the cycle. ATP provides energy, while NADPH donates high-energy electrons. Together, they convert 3-PGA into a higher energy molecule called G3P. G3P is important because it is the direct product that can be used to make glucose. For every 3 CO2 molecules that enter the cycle, 6 G3P molecules are produced. However, only 1 G3P leaves the cycle to help form sugars. The other 5 stay behind to keep the cycle running. For simplicity's sake, in this video, the numbers of the products are divided by 3. So 3-PGA is now PGA, and G3P is broken into thirds. So 1/3 G3P, or 1 carbon, is saved to help form a sugar. The saving of carbon marks the end of the reduction phase. The 5 remaining G3P molecules are rearranged using energy from ATP. Through a series of reactions, they are converted back into 3 RUBP molecules. Once again, for simplicity's sake, in this video, the numbers of products are divided by 3. So 5 G3P is now 1 2/3 G3P, as 5 G3P has 15 carbons. Dividing that by 3 leaves us with 5 carbons, or 1 2/3 G3P. Although 1 G3P leaves at a time, it takes 2 full turns of the Calvin cycle to make enough G3P to form 1 glucose molecule. This process is how plants store energy from sunlight in the form of sugar, forming the base of nearly all food chains on Earth. That is the end of the Calvin cycle. This was made by Addison, Julian, and Shivali. Thank you and have a wonderful day.